So the answer to this first question is k. And that's because, well, we've already gotten rid of any vertices that have k plus 1 edges or more. So all the remaining vertices can have at most k edges connected to them. Now, to answer this final problem, we have to remember that we said earlier that at most k vertices are needed to cover the entire graph. Well, if there are k vertices necessary to cover the graph, and each vertex has at most k edges attached to it, then the remaining graph can have no more than k squared edges, since we have to cover all of them. Now, this might have seemed a little involved, but there's actually something powerful here. What this means is that after doing all of these little pre-processing steps, then we either know that the graph G is not a yes instance of the vertex cover decision problem, in other words, it's a no instance, or we know that the size of the resulting graph is bounded not as a function of n, which it was originally, but rather as a function of k. And remember we said earlier that very often k is far less than n. So this is potentially a very big win for us.